Okay, so a quick recap on what I did with you guys last week, which is when we started electrical. Remember, we looked at a few rules in electricity. The most important rule is Ohm's law, which was V is equal to IR, where V is the voltage. Sometimes V can be also called as EMF, electromotive force, or even potential difference, right, which I talked about last time. I is your current, and R is your resistance, all right? This is the most important rule you should know in electricity in general. This is what is used to for in everything and applying it in circuits, or just in applying it for any resistor when you're trying to find voltage or current. And the easiest way to remember it is by drawing the triangle to remember this equation, depending on what you're trying to find. So you would put voltage up, current down, and resistance down. And whichever we are trying to find, you will select depending on how you are solving. طبعا in the exam, you guys will have a formula sheet where this equation is written, the V equals IR. So you don't really need to memorize it, but أهم شيء you guys understand how to use it. Remember that the voltage is going to be in volts, the current is going to be in amperes, the unit يعني, and the resistance is going to be in ohms, right? Which is given by this symbol. This we covered very thoroughly last time in the last session. You guys can refer to that video if you want to get a quick refresher. Then the other rule we looked at was the power law, which is power P is equal to the voltage times the current. All right. So again, this P is just power. In watts, that's the unit. Voltage is in volts and current is in amperes. This is to find the power. Again, you can draw the power triangle, very similar to Ohm's law's triangle, but the difference here, power is going to be up, and you have voltage and current down. All right. So again, if you were trying, for example, to find voltage, it's going to be the power over, and if you want to find voltage, it's going to be P over I. All right. If you're trying to find current, it's going to be P over V. And if you're trying to find the power, it's going to be V times I. All right. This is how you would look at the triangle. Another thing we covered last time, this is just a refresher again. We know that power is equal to energy over time. Again, this is energy or electrical energy. All right, this is usually in joules. Time is in seconds, and power will be in watts. Okay, another unit, usually another form of this equation, is going to be energy is equal to power times time. And sometimes you can have the unit be either the same way, where it is joules, watts, and seconds, or sometimes the units can be given as kilowatt hour. This is as kilowatts, and this is in hours. All right, just make sure that you are consistent. Again, we covered a lot of questions using this, and you can apply it in either form. And if you know how to do the conversions, it is the same, because remember, joules is simply watt times second. All right, so if you do all your conversions properly, you can manage to get it in this equation. But this was all from just a refresher from the last session. Today, what we want to look at is how to apply these when we have a circuit. So what is a circuit? A circuit is basically a representation, a diagram that represents an actual electrical connection between a component and a source. The source يعني, being a voltage source providing energy or providing power to a component. So let's say, for example, we have this basic circuit. All right. This means this is a voltage source, or to be more specific, this is a single cell, okay? And the longer side is positive and the shorter side is negative, all right? So the longer side here is positive and the shorter side is negative. This is just what provides voltage or provides the power for the circuit. And usually you will be given a voltage, let's say, for example, here, 10 volts from this source. So this source is providing 10 volts to this circuit, all right? And this symbol, if you draw it like this or draw it like this, it's the same thing. This is a resistor, right? And remember, a resistor, the unit of it is in ohms, all right? So they might give you something like 30 ohms here, and this is the resistance value of this resistor. Now, if you remember last time, current is always flowing from the positive end, all right, to the negative end of the battery. So it exits the positive side, which is the longer side. This is our current I, all right? And it is going back to the negative, all right? Current, basically what this is, these are just wires, all right? يعني هذا, this is just wiring. Wires connected to a component from both sides of a battery, okay? That's all that this is. You just have a positive side, a wire that's coming from the positive of the battery, and then a wire coming out of the negative, and it is connected to the component on both sides. All right. So another thing you guys need to consider is direction. I know generally it is not a big deal, at least at this level, but I like to explain it because it will make your life much easier later on, especially when you go into your first year. So I like to explain it from now. Direction meaning the polarity, all right? Polarity meaning plus or minus. So polarity of something means the positive or negative ends of it. So in this case, if you look at the cell, it's always identified because we always know the longer side is going to be positive and the shorter side is going to be negative. So this is what they call the polarity of the voltage source, or in this case of the cell, all right? And we know that current is flowing in this direction. It's going that way. So wherever current is flowing, this will generate a polarity on the resistor as well, depending on the flow of current. So if current is going from here in and out from here, this will become the positive end and this will become the negative end. Remember that current will always, in a component, enter from the positive and exit from the negative, opposite of a cell. So when we're talking about polarity here, it will look something like this for a component, or in this case for a resistor. Tamam? Since you guys are only dealing with resistors, I will be talking about resistors, not any other components. Polarity is not that important right now at this level, but I want you guys to understand that when current is entering any resistor, wherever the direction of it going in is going to be positive, and wherever it is going out is going to be negative. This is just a small concept you guys should know for later on. So now, how can we apply what we know, which is Ohm's law, to find out the current in this circuit? So remember, we have our voltage, okay? Our voltage source is 10 volts. So we have our V and we have our resistance, which is our 30 ohms. We have our resistance. So what we need to find is our I. So how can we do this? Either by rearranging this equation or by using the triangle. We know that I is going to be voltage over resistance, which in this case is going to be 10 over 30, which is 0.33 amperes. Since all the units are correct, the voltage is in volts and the resistor is in ohms. Again, I did explain this previously, but now I just wanted to go a bit more in detail. So this is how you how to analyze a basic circuit. However, most circuits ما عندنا احنا بس resistor واحد، يكون في two resistors, sometimes three, sometimes four, and they're connected in two different ways usually. And I will cover that right now. So the first way resistors can be connected is called in series. What does this mean? So a series connection. So we will have a voltage source or a cell or even a battery, which is a group of cells. All right. This is simply just a battery. All right. It's the same thing. The longer side is going to be positive and the shorter side is going to be negative. The same exact idea. So plus, and here it's going to be minus. When it is a group of cells, so it's more than one of these, that's basically just a battery. All right. So this is a battery, and then it is connected now to more than one resistor. So let's say we have a resistor over here, and then another resistor over here. Okay. Now, if you notice, we do not have one single resistance, so we cannot directly simply apply V equal IR very easily because we have multiple resistances. However, there is a way to analyze this and simplify this depending on the type of connection. So I mentioned that this is a series connection. What does that mean? A series connection means connected at one point. Meaning, all right, these two resistors, they're connected to each other through just a single point in between them. That means that these two are in series. All right. Why? Because there's only one connection point between them. They are not connected on this edge. They are connected to the battery from the other side. Hello? Okay. So a series connection means that there's only one connection point between the two resistors. So let's give these values. Let's say the battery is 15 volts. Let's say that this is 20 ohms and this is 30 ohms. Okay. So when they're connected in series, how can we understand the values and how can we apply Ohm's law and all of that? So the first thing is series has its own set of rules. First thing, let's look at the resistances. So for the resistances R, or resistance, to find your total resistance here, you can simply say that R total, all right, RT meaning R total, is going to be equal to, let's say this is R1 and this is R2, R1 plus R2. So this is your first important rule, that resistors and series are just going to be added up directly. All right, so when you have two resistors in series, to find their one total resistance, you can simply just add up the resistors and you will find your total resistance. So if I want to just copy paste this down here again, okay, so the same circuit can be redrawn now. We can remove these two resistors and put one resistor in its place instead of two. And this is going to be our R total. Okay? And what is the value of R total? It is equal to R1 plus R2. The value for R1 was 20 ohms. So we know that R1 is equal to 20 ohms and R2 is equal to 30 ohms. So when they are connected in series, we can apply this equation. So we know that R total is going to be equal to 20 plus 30. So R total is equal to 50 ohms. So we know now that this resistor has 50 ohms. So this circuit is equal to this circuit just by reducing the resistor. This is what they call reduction of resistors. يعني بما معناه قاعدين نقلل عدد الرزسترات باستخدام الفورمولاز اللي نعرف عشان نقارنهم ويا بعض. تمام؟ So this is the main first rule when it comes to a series connection. The second rule, all right, so if we're looking at the main circuit again, the second rule is the current is the same throughout the entire circuit. So current is not changing. Let's call this current I. Okay. الكرنت هني نفس الشيء كل مكان ما يتغير في الريزستور في السيريز connections. So we can also say now that current I is equal to the current I1, which is also equal to the current I2. What does this mean? Current that is flowing through resistor 1, all right, this current is the same as the current flowing through resistor 2, which is the same as the current that is flowing throughout the entire circuit. يعني the current here, let's say that this is I1 and the current here I2, they are also equal and they're equal to the same I, which is I1 and I2. All right, because current is the same all throughout the entire circuit from the battery all the way back to it. So this is another relation we can use later on, and I will show you how in a bit. But this is a very important one that you need to know as well, that current does not change in a series circuit. The last thing, so we looked at resistance, R. We looked at current, I. The last thing we need to look at is voltage, all right? So let me just copy paste this one more time. So if we want to talk about voltage, so the voltage here, it is being supplied, which is 15 volts, all right? However, the voltage, this voltage is going to be split up across these two resistors, okay, in a series connection. That is the idea of voltage. So voltage is going to be split across resistors. In other words, بما معناه يعني ال V total or V source, okay, I usually like calling this V source, and the voltage of the source, which is 15 volts, is going to be equal to the voltage from R1 plus the voltage from R2. يعني we're going to have a specific voltage over here, voltage R1, and then we have another specific voltage over here, VR2. What does this mean? The sum of these two voltages has to be equal to the voltage that is at the 15 volt supply. يعني when you're adding all the voltages that is being dropped across these resistors, when you sum them up, you have to have the sum which is being supplied by the voltage source itself. شو معناته هالشيء؟ الريزستور, when voltage goes through a resistor in بشكل عام, زين, when you have a wire, okay, and you have a resistor, let's say that this is a 10 ohm resistor, زين, you have a specific voltage هني. Let's actually color code this. So you have a specific voltage going through this line. Let's call this 20 volts. Okay. Depending on the circuit, obviously, this resistor is going to reduce the value. Yani when it's going here, it's going to reduce the value of the voltage, because remember, current is not changing. Current is the same throughout the circuit. So this resistor is going to drop the voltage, in other words. So let's say, for example, depending on the current, this might be 2 volts now. Okay. So in other words, yani, there's going to be a voltage drop from 20 all the way to 2 volts. And this voltage drop is going to be 20 minus 2 volts minus 2, which is equal to 18 volts. This 18 volts is the voltage drop that you are getting across this resistor. This is what this means. يعني بما معناه, this resistor is reducing the voltage coming in by 18 volts لأن current is the same. So it's reducing it by 18 volts. So it's coming out of it, after it, it's coming out as 2 volts. This is what this basically means. Okay. So this is what a voltage drop is. So obviously the voltage, when it's going from 15, this and this, whatever is being dropped, has to be equal to 15 when you sum them up. All right, so let us make it a bit more clear now. So now let's just recap very quickly. We know in R total, اللي هو total resistance, يساوي addition of the two resistors. So whatever resistors are in series, we're going to just add them up to find R total. All right, and remember, current is the same throughout the circuit. So the current here as well is the same. This current does not change at all in a series connection current I. All right. And the voltage is going to drop across each resistor, and you're going to have a value for the voltage drop for each one. Okay. So now let's try to find these values. How can we do that? Simply using Ohm's law. But how do we apply it? So the very first step you guys should do is let me actually just copy paste this so I can write down the steps for you guys as well. So the very first step usually is finding the total resistance. All right, so step one. Find R2, which is total resistance. Okay, that is usually your first step if you are trying to find all the values here. All right, so for our first step is to find our total resistance. How do we do that? I already showed you guys. R total in a series circuit is R1 plus R2. So R total is equal to R1 plus R2, which is 20 plus 30. So R total is equal to 50 ohms. Okay? This is our very first step. It's finding R total. When we find R total, we come with this, we get this circuit, which is the equivalent. And then this circuit is what we get after finding step 1. Applying step 1, we find a circuit with R total of 50 ohms. Step 2 is finding your total current. Step 2, find I. Now, if you notice, this is a much more simpler circuit that we can analyze. Why? Because we only have one singular resistor, and early on we already were able to find the resistance for one the current, for one resistor in any circuit, which is by applying V equal IR. So this is what we are going to do to find I. Find I, and I'm going to put between brackets using Ohm's law. Tamam? This is going to be your second step. So how do we do that? We know that Ohm's law says that I is equal to the voltage source Vs. In this case, I'm calling this Vs. So the voltage V, or the voltage source Vs, equal to, divided by, the total resistance over here. So this is just, again, Ohm's law, but the only difference is now we're talking about the total voltage source, and we're talking about the R total, because our original circuit, we have two resistors. So I need to clarify which resistance I am talking about, but it's just Ohm's law. All right? So we can find that simply by doing 15 divided by 50. So we know now that our current I is going to be equal to 3 over 10, or 0.3 amperes. Okay? So now we have found our total current. This is our step 2. So if the question asks find the current of the circuit, the current going through any resistor or anything, we can find it. Why? Because we know that I is equal to I1, which is equal to I2, meaning this I1 is current flowing through R1, yani the current that is flowing through the first resistor, and this I2 is the current flowing through R2. Okay? R2. So for example, if the question says, find the current that is flowing through R2, you know that you need to find your I total in this way. We're using the first step to find the total resistance. And then once you find your total resistance, you can find your current. Tamam? And we know that this total current, because this is a series circuit, remember, we are only talking about a series circuit right now. Since this is a series circuit, we know that current I1 is equal to current I is equal to I1, which is the current through first resistor, and it's also equal to I2, which is the current through the second resistor. Tamam? So we know that all of these are all equal to 0.3 ampere. Now let's look at step 3. So step 3 was we are trying to find the voltage drop across each resistor, okay, which is our VR1. So we remember when I said we have a voltage dropping here, okay, call it VR1, and we have another voltage drop here, we will call it VR2, okay? So VR1 is the drop from the first resistor, and VR2 is the drop of the second resistor. Yani how much voltage is it reducing? All right, that's what that means. So step 3, find VR1 and VR2. Again, we are going to be applying Ohm's law. How do we apply Ohm's law in this case? We now have the current that is flowing through both. We know that this current here, okay, I is equal to 0.3 amperes, 0.3 amperes, 0.3 amperes, 0.3 amperes. This whole current, all of it is 0.3 that is flowing throughout the entire circuit, I, okay? So we know that our I1 equal I2, which is just equal to I, is equal to 0.3. This we found from the previous step. And we have the resistance R1, which is equal to 20 ohms. And we have our resistance R2, which is equal to 30 ohms. But now we are trying to find the voltage. So the voltage across R1 is going to be equal to I times our I1 times R1. Same thing with VR2. Applying Ohm's law, we know it's going to be I2 times R2. But since I1 and I2 are equal, they're also equal to I, we can simply just say that this is VR1 is equal to I times R1, and VR2 is equal to I times R2. It's the same thing because current is the same. And now we can just plug in our values for both to find out our voltage drop across each resistor. So I is equal to 0.3 amperes and R1 is equal to 20 ohms. So we know that VR1 is going to be equal to 6 volts. All right? If you multiply 0.3 by 20, that's 6 volts. Same thing for VR2. That's equal to 0.3 times 30. So VR2 is equal to 0.3 times 30 is going to be 9 volts. So now we managed to find the voltage drop across each of these resistors if they ask for it. So if they're asking for what is the voltage across or the potential difference across resistor 1 or the voltage drop across resistor 1, any voltage when it comes to resistor, it's either a drop or a difference. If they're asking for that, you know how to apply these steps by using Ohm's law, by first finding the current and then finding it depending on each resistor. Let us check, okay, to check. Remember what I said about voltage in a series resistor. In a series resistor, the voltage, where did I write that down? Yes. The voltage is split across the resistors depending on the given voltage source. So in other words, the voltage source should be equal to VR1 plus VR2. So when you're adding the drops, these two drops, they have to give you the total voltage, which in our case is 15. So in other words, we know that Vs is 15 volts, and we know that Vs is equal to VR1 plus VR2. So Vs is going to be equal to VR1 is 6 plus VR2, which is 9. So Vs is equal to 6 plus 9 is 15 volts. So we know that this is correct. All right. So this is how you will be applying for any series circuit. This is how you'll be able to find all your unknown values. Usually in a circuit, you are given the voltage source, the voltage of the voltage source, and the resistance of the resistors, and that's it. And everything else you need to be able to calculate from your side. All right. In the case if we have more than 2 resistors in series, so for example, let's say we have something like this, and we have 1 resistor here, 2 resistors here, 3 resistors here. Okay, so R1, R2, R3. Again, the same ideas will apply. Our total is going to be adding up all the resistors because they're all in series together. There is 1 point of connection between R1 and R2, and there is 1 point of connection between R2 and R3. All right, so since there's only 1 point of connection, that means they are in series. So you can just add them all up to find our total, and then you can find I, which is the same through I1, same for I2, same for I3, all right? And it is going to be equal to using Ohm's law, Vs, where this is our voltage source, over our total. And once you find this, you can find VR1 using Ohm's law again. So VR1 is the voltage drop across R1. So it's going to be I1 R1, or in other words, IR1, since all of the current is equal. VR2 is going to be I2R2, or in other words, it's simply IR2. And VR3 is going to be I3R3, or just simply IR3 because all of the current is equal. And then you can check by using this equation, which is the total voltage coming from the voltage source, has to be equal to the total voltage across all the resistors that are connected in series. Again, remember, this is only for a series connection. Tamam? So this is VR1 from here to here, and this is VR2, and this is VR3. Okay? Is series connection clear? Does anyone have any questions before I move on to the next one, which is parallel? Clear? All right. Let us move on to look at parallel circuits, and then we're going to solve an example for each. So احنا خلصنا من series circuit. So now we have something else which is called a parallel connection or a parallel circuit. Okay? Before actually moving on to parallel, I want to mention one more thing, so you guys don't get confused when you look at circuits. So let me actually draw one in here. So let's say we have this circuit, all right? And let's say that this is R1 and this is R2 and this is VS. Okay, a simple series connection. This is the same as the circuit exactly. If you have, for example, this is the same exact thing, all right? These are also two connected in series. Remember that these are just wires. هذول بس وايرات يعني يتحركون تقدرون تحركونهم يمين يسار فوق تحت. These are just wiring. So it doesn't matter where you are moving the component along the wire as long as يعني you're not changing the location of the component. These are just the sets of wires that you have in your connection. All right? So if we look at it in this, now this wire has become just shorter. That's all we did. And this orange wire has become a bit longer. And the purple wire has become a bit shorter as well. It's the same exact connection. Okay, remember, just wires in real life. إذا عندكم واير شارجر إذا حركتوه يمين يسار وحطيتوه فوق وهذا وموصلينه في التليفون, it will still charge the phone. It's just a wire. Okay, it doesn't matter how short or long the wire is. All right. So these two circuits are exactly the same. Also, if you want to draw it like this, or if it's given to you like this, again, same idea. This is R1, this is R2, same exact idea. These are all the same circuit. If you look at it, this is the wire that is connecting the voltage to R1. Now the orange wire has just become longer, and the purple wire has become shorter. But these are still connected in series. Remember, connection in series means 1-point connection. Okay, this basically means series. Yani, here we have 1 point of connection only. Here we have 1 point of connection only. Here we have 1 point of connection only. All right, this is one singular wire. Do not think that this is a connection here and this is a connection here. No. It is only one single point because this is one wire connecting both of them. Yani 1 point of connection meaning one wire connecting them. Okay? Think of it that way. فيوم يكون بس واير واحد موصلهم في بعض, that means they are connected in series. Okay? Let's look at a parallel connection. A parallel connection, what does it mean? It means 2-point connection. In other words, يعني عندكم two wires. All right, and let's look at how that would look in a circuit. Let's say we have our battery in this way. We have a resistor here, and we have a resistor here. Okay, so this is our voltage source VS. Let's say it is 10 volts. This is our 20 ohm resistor. Okay, we'll call it R1. And this is R2, which is, let's say 30 ohms. Let's keep the same numbers here. Okay, instead of 10, let's keep this 15. So we can be consistent with the numbers. Now, if you notice, there are two wires connecting the resistors. Okay, we have 2 points of connection. We have this wire that is connecting these two resistors. And we have this wire that is connecting the two resistors. Okay? So these two wires are connecting the resistors. معناته we have two connection points. In other words, معناته this is our first connection. This is our second connection. Therefore, these two resistors are connected in parallel. Okay? This is what a parallel circuit looks like. تمام? An easier way of looking at it is, by putting your connection points over here so that you understand. And now, okay, if these are connected, they're connecting up and down, they're connected to each other, if it makes it easier for you guys. But the idea is there are two wire connections for each, and the same wire is also connected to a voltage source over here. Okay? Tamam? So this is what a parallel circuit is. So the first thing we look at is, let's look at the resistance. The rule for two resistors in parallel, or resistance in parallel in general, is equal to R total, or I should say 1 over R total, is equal to 1 over R1 plus 1 over R2. Again, this equation, they will give it to you in the exam. You don't have to memorize it. You just have to understand that this is the equation for a parallel circuit. Okay? So this is the relation of how we can find our equivalent resistance, or our total resistance in the case of this circuit. So if we want to do that, we just plug in our values. So 1 over RT, R total, is equal to 1 over R1. R1 is 20, so R1 is equal to 20 ohms, and R2 is equal to 30 ohms. So 1 over RT is going to be equal to 1 over 20 plus 1 over 30. So 1 over RT is equal to, put that into the calculator, 1 over 20 plus 1 over 30. It's going to be 1 over 12. Okay, remember this is 1 over RT. This is not our total. Our total, we have to do the inverse. Okay, so we have to basically swap up and down for both sides. So this is the same as saying RT over 1 is equal to 12 over 1. Okay, or in other words, our total is equal to 12 volts. If you notice, when you connect two resistors in parallel, the resistance actually becomes less, not more. Opposite to what we saw in series. In series, what we did is we added the 20 with the 30 and we got 50. So it became more. But when you have a parallel connection, the resistance actually becomes reduced. It becomes less. This is not volts, this is ohms. All right? So the resistance becomes less when you're connecting in parallel. So you can apply this formula when you have two resistors in parallel. In the case of only two resistors, okay, in the case when you have only two resistors, I believe this formula is also given in the formula sheet. You can use this formula directly, which is RT is equal to R1, R2 over R1 plus R2 to find your R total. All right. This is just a simplification of this form so that RT is directly found. So in other words, you could say that this is equal to 30 or 20 times 30 over 20 plus 30. And it is going to also give you 12 ohms when you put it into the calculator. All right. Again, this is in the case of only two resistors. All right. This is only when you have two resistors. When you have three resistors, you cannot use this form. All right. You have to put R1 over RT equal 1 over R1 plus 1 over R2. And then you're going to write plus 1 over R3. And if you have more, you're going to put 1 over R4 and so on and so on. All right. Do not put R3 here and then plus R3 here. This is completely wrong if you have more than two resistors. So if you want to use this shortcut, you can use it only for two resistors. Okay. So this is how you find your total resistance. Let's us look at voltage this time instead of current. Before that, so if we use this formula, all right, now you will notice that our circuit is gonna be reduced, or our resistors is gonna be reduced. So I can remove this part. And now we're gonna have one singular resistor in this fashion. It's gonna look this way. And this is your R total, which is equal to 12 ohms. Okay? This is what it will look like. So this circuit is equal to this circuit up here. It's the same exact circuit. The only difference is we simplified it, so we have R total. Let us look at current. I. Okay? Let me bring this down here. Let me remove all the highlights. So last time when we looked at a series connection, we had all the current be equal to each other. In the case of parallel, that is not the same case. In the case of parallel, if you notice, we're gonna have just one second. Okay. So in a parallel circuit, current is not going to be all equal to each other. Why? Because let's say that this is the current that is leaving the battery. Okay, let's call it IT or I total. Okay, this is the total current that is leaving the battery. When it comes here, it is going to split into two directions. When it comes to this point, it is splitting the current. Okay, think of it as pipes. If you have one pipe over here, all right, if you have one water pipe, so what you have a pipe like this, and then you have a connection here like that. All right. So if you have a pipe here, the water is flowing. So let's say that there's a specific volume of this water flowing here. It is going to split into two directions. So this is no longer equal. So there's going to be less amount of water flowing up and down. It is not going to be the same as the total current. But we know that at this point, that the current here has to be equal to the total sum of the two currents over here, which we will talk about later, which is current. Actually, we talk about it later for KCL as well. But since I'm already explaining this point, might as well. So if we say that this is our total water, all right, or in this case, we call this current total. This is our IT. Okay. It is going to be split into two parts. So the sum of the water is going to go down here, and some of the water is going to keep going up here, or in this case, in the circuit, in this direction. Okay? So let's call this, for example, I2, and let's call this I1. Obviously, the sum of these two currents has to be equal to the current that is coming out, because anything going in has to be equal to anything that's going out. So I total is going to be equal to I1 plus I2, right? This is also known as Kirchhoff's current law, but we will look at that more detail later on. But if you notice here, if you're thinking of it as water flowing through a pipe, أي ماء قاعد يطلع من هني حتى لو بيتوزع لو بنرد نجمعهم لازم يساوون الماء اللي قاعد يطلع من البداية. Therefore, the same idea applies to current. So I total is going to be split into two currents through this node. They call this a node, all right? This is a node. المسمى مال a point, a connection point, they call that a node. If you notice in a series circuit, what was split? The voltage was split, all right? But here, the current is being split because the wiring has been changed, all right? We have this wire being split into two directions. So the current here is going to be flowing this way. Current here is going to be flowing this way. This is I2, and this is I1, all right? And if you notice, this current is going to come back here. Now here we have the flow being in the opposite direction. So it's looking something like this. So if you have water flowing, actually it's the opposite way. So it's going to be something like this if we're thinking about it as water. We know that this is I1, right, going into that direction, and this is I2 going into this direction. They're going to get combined in the middle here, right? This is going to combine with this, and they're going to go here. And when these two are combined, you're getting back your total water flow, which is your I total in that direction. So we know here, this is going to also be I total, which is going back. Tamam? So the main concept here is when you have a node, yani when you have a wire that is being split up into two locations, into two directions, the current is also going to be changing. This is what is known as a parallel circuit for current. Current is not going to be consistent. ما بيكون نفس الشيء. بيتغير. ولازم when you sum up all the current that is being split up, it has to be equal to the total current that is going out. All right? So let's look at this now in the case of when we reduced the circuit. So when we reduced the circuit, we combined these two, right? Now we did the combination, the parallel combination, where we did 1 over RT equal 1 over R1 plus 1 over R2. Okay, we did this combination here. And then we found out that this is our R total. Remember that the current that is coming out of the source does not change. This current is the same current. So here, the current that is going out of the source does not change. But now we only have one resistor because it's just a single resistance. It's a basic circuit. So this is still our same I total. And now we have the value for R total and we have the value for VS. We can find the value of I total over here from this circuit. This is the whole idea of reducing two parallel resistors. عشان يوم تبون تحصلون الكرنت توتال تقدرون تحصلونه بسهولة. Using what? Using Ohm's law. IT is going to be equal to VS over RT اللي هو 15 divided by 12, which is going to be equal to 1.25 amperes. All right. So this is how you find your current total throughout the circuit. You can find it by using your V equal IR equation, and you can then apply it to find your I1 and I2, and I will show you how also using Ohm's law. So we talked about current. Let us talk about our last thing, which is our voltage. So what about voltage? So remember earlier, I was talking about voltage. And I said that voltage in series, if you notice, the voltage is dropping or it is changing from the example that I explained here. So voltage, when it is going through a resistor, it is dropping, it is changing with a specific value. For example, here assumed it's 18 volts. So when it goes through a component, voltage changes from 20 to 2 volts. But current was not changing. The current here was consistent, right? Our current here is the same. I did not change. But the voltage changed. The exact same concept here we will be applying. So notice here that voltage changed, the current, sorry, was changing through the node, all right? The current changed over here when we were at this node over here. The current changed. However, the voltage that is coming out from here, let's use blue. The voltage that is coming out is the same entirely throughout the wires here. It does not change. The voltage here is all 15 volts. It is not changing. يعني بما معناه VS is going to be equal to VR1 and VR2. So VS is equal to VR1 equal to VR2. ليش؟ لأن in parallel we are not going through any components through the wires. يعني we are going through the component only when they are in parallel. So when you do a voltage drop here, you are just coming back directly to your voltage source. All right. So because of that, VS is going to be equal to VR1 and it's equal to VR2. There is no component basically connected here that is reducing your voltage. تمام? An easier way to understand this is usually we have something we identify called ground. All right. This is just some extra information. It might be helpful, it might be not. The ground, if you remember before, I was explaining voltage. If we're talking about a building, then if we're talking about a building, we say that the height of this building, for example, is 20 meters. For example, it's 20 meters. But 20 meters from where? We are using this as our reference point, which is the ground. صح ولا لا? This is what we call our ground. And this reference point, the height here is 0 at this point. يعني this is our 0 point. حلو؟ يعني هني نبدأ من الصفر. فاحنا لو بنجيب متر او وات ايفر او فيتا او هذا بنقيسه من هالمكان، وهالمكان اللي احنا بنسميه our reference or our ground. نفس الفكرة عندنا بالفولتج. This is what we call our ground voltage. Okay, we usually decide a specific place where we have our ground voltage. تمام? It doesn't usually matter where you identify your ground is, as long as it is just consistent. And usually the ground voltage is going to be next to the negative side of the battery. So this is the negative and this is the positive. عادة, we usually look at the negative side to be our ground. Why am I saying this to you guys? لأن the ground, like I said here, our ground was H equals 0. This ground voltage V0 is also assumed to be at 0 volts. This is just our reference point. Okay? معناته, when we said that Vs is equal to VR1 equal to VR2, ال Vs عندنا يا 15 volts صح؟ ف VR1 is equal to 15 volts و VR2 is also equal to 15 volts. Remember what I said about the voltage drop. When you're going through a resistor, then we will have a specific voltage here and a specific voltage down here. وبيكون عندنا الفولتج دروب اللي هني تكلمنا عنه. For example, VR1 is 15 volts. Okay? هني the blue part, now we know that they're in parallel. We know that there is 15 volts coming from there. There's 15 volts here. So we are dropping it by 15 volts. In other words, we are saying it is 15 minus VR1 اللي هو الفولتج drop because of VR1. So we're doing 15 minus 15 ونوصل للground voltage مالنا which is 0. This is what is meant by a voltage drop. معناته the voltage is changing when it is going from one point to the other. All right, this is just extra information. You're going to be using this a lot later on in electrical circuits, but it is a good concept to understand as it makes it much easier to know what they mean by a voltage drop. يعني الدروب قاعد بس يقلل الفولتج from one location to the other location. Anyways, back to the main concept. When it comes to a parallel circuit, Vs is equal to VR1, which is equal to VR2. The voltage is going to be the same for everything. How is this important to us? Because now, if I look at the circuit one more time, we know that we have a voltage. We know now that our VR1 is equal to 15 volts. And we have R1, which is equal to 20 ohms. We can now find our current I1 using Ohm's law. Remember that I1 is equal to VR1 over R1. All right? And remember that VR1 is equal to V. Yani these are all just equal to the voltage. So a better way to explain it is Vs is equal to VR1 is equal to VR2, which we can call them all simply as V, our voltage V, which is 15 volts. Okay? So IR1 is equal to VR1 over R1, or in other words, we can simply say it is equal to V over R1. تمام? And we have the values for all of these. We know that R1 is also equal to 20 ohms. So now we can find out that I1 is equal to 15 volts over 20, which is 0.75 amperes. Okay? Same exact thing we are going to be applying for I2 now. So we know that I2 is equal to VR2 over R2, or in other words, since voltage is the same everywhere, it's V over R2. And we know that R2 is equal to 30 ohms. For now, we can find out that current I2 is equal to 15, which is the same voltage, divided by 30, which is equal to 0.5 amperes. So now we found our current that is flowing through each resistor. تمام? To check, remember, what did I say? I said that I total has to be equal to the sum of I1 and I2. So I total is going to be equal to I1 plus I2. تمام? If we check now, I total, we know that I total is equal to 1.25 ampere. We found that earlier here from using the total resistance circuit. When we did our V total and R total, we managed to find our I total, which is which was 1.25 ampere. All right. So to find the current now in each one, we did the same thing. So this is equal to I total is going to be equal to I1, which is 0.75. This is just to check, plus 0.5. And we notice that I total is equal to 1.25 ampere. So this is also correct. Okay. This is how you would analyze a parallel circuit. Now, as you can see, all we did was use Ohm's law and the relations for parallel and series. All right. Again, if we do have a parallel circuit where we have more than more than two parallel connections, something like this. Okay. So let's say this is R1, R2, and R3. This is V total or V source. All right, you're going to have a current here that is your I total. Then you're going to have a current here I1, a current here I2, and a current here I3. All right, you're going to have a current for each and every one of these. First thing, if you want to find your I total or your total resistance, R total, let me see, how did I do it here? Steps, okay. Let me do the same thing here. Let me write it in steps so you guys have a good general idea. Okay, so I will say step 1. Find R total. All right, that's the same, similar in parallel or in series circuit. Find R total. How do you find R total for a parallel circuit? It is 1 over RT, 1 over R1, plus 1 over R2, plus 1 over R3. Remember, since we have 3 resistors, we cannot use this equation. We cannot say R1 times R2 times R3 over R1 plus R2 plus R3, right? This is completely wrong. Okay? Do not apply this equation when you are doing, when you have more than 2 parallel resistors. So this is your first step, is finding R total using this equation. Then you are gonna be left with a circuit like this with 1 resistor only. So you'll have the same I total current going here. This is Vs and this is R total. So step 2 will be now find I total. I total using Ohm's law. How do you find I total? I total is V total or V source in this case over the total resistance. Okay. Step 3 would be finding your currents I1, I2, and I3. So last time our step 3 was finding our voltage drop. In this case, we know our voltage drop because Vs, first of all, we need to find I1, I2, and I3. Again, using Ohm's law. Okay. Now, we do not need to find voltage drop because we already know that Vs is equal to VR1 equal to VR2 equal to VR3 because this is a parallel circuit and we'll call them all V. Okay, they're all equal to each other in terms of voltage. So we can apply Ohm's law for I1. It is equal to VR1 over R1, or in other words, it is V over R1. Same thing for I2. It is equal to VR2 over R2, or in other words, V over R2. Same thing for I3. It is equal to VR3 over R3, or in other words, simply V over R3. And that's how you'll be able to find your current through everything. The last part is checking, if you like. I total is going to be equal to all the currents, which is I1 plus I2 plus I3. Is this clear? Is this clear for everyone? Does anyone have any questions about this? This is the method for solving any series or any parallel circuit you might see. After this, I will cover also a combination circuit so you guys know how to reduce the circuit if you like. But before that, let us take just a 5-minute break. All right. Let's make it a 7-minute break. So we'll be back at 2:20 p.m. All right. If you have any questions, feel free to ask right now about what I have done. I'm going to be around. Take a break until 2:20 and we will continue with combination circuits. Okay, so we talked about series and parallel. Let's just do a small, quick revision on both. So you remember the most important things you need to know about both. Okay, so we have our series and we have our parallel. Okay, in series, our resistance, total resistance is going to be R1 plus R2 plus R3. Our current is going to be all equal I2 equal I3. Our voltage source or voltage total is going to be equal to the voltage drop across each one. So VR1 plus VR2 plus VR3. And the last point I didn't talk too much about, but I will talk about now, is also power. If you want to find power, okay, power P, remember, if you're trying to find the power supplied, it is going to be equal to the current, since the current is the same across the entire circuit, times the voltage supply. Simple, all right, to find the power supplied. But let's say we want to find the power absorbed by a specific resistor, all right? So let's say the power absorbed for R1, it is going to be equal to I, since current is the same, squared times R1. All right. And if it was for R2, you're going to be doing R2. And if it was R3, it's going to be R3, since current is the same everywhere anyways. Okay. Remember this, I already explained how we got this formula from before, how to get power and all of that in the previous session. You can refer to that. But it's very simple. If they ever just ask you for the power dissipated, it means power or power absorbed. You know how to find it for any resistor. And if they're asking for power supplied, you can just multiply I by Vs. What about parallel? We know that 1 over RT is going to be 1 over R1 plus 1 over R2 plus 1 over R3. Okay, the current here is now no longer all equal, so the total current is going to be equal to I1 plus I2 plus I3, and the voltage now is going to be all equal in a parallel case, so VR1 is equal to VR2, which is equal to VR3. To find now the power supplied, it is going to be equal to I total, the total current, because that's the current that is going throughout the entire circuit, times the voltage supplied. And to find the power absorbed or the power dissipated, it's the same thing. For example, for R1, it is going to be I1 squared, so the current that is flowing through the first resistor, times R1. And if it was for R2 or R3, you're just going to put I2 and I3 instead. Okay, so this is just a simplified table for how it will look like. Let us look at the case where you have more than one circuit, as in a combination circuit basically of series and parallel. All right. So let's start with a simple case. So let's say that we have our voltage source up here. Okay. And then you have a resistor like this. And let's say another resistor down here. Okay. So the first thing you're going to do is you're going to look at the connection of your resistors. You're going to have to identify which ones. Let's call this VS. Let's call this R1, R2, and this R3. All right. So first thing you're going to have to do is you're going to have to understand how to reduce the circuit, how to make this all equal to one resistor, and then you can find out any other value you might want to find. What I'm only going to focus on is V total, or the V source, and the I total, because that's what will be coming in your exam. So remember that I total is basically the current that is coming out of the positive side. This is your I total, all right? But how are we going to simplify this? So first things first, you notice here that this is going to be a series connection. So we know that these two are in series. Why? Because they are connected at one point only in between them. There's only one point of connection between them. So you can simplify the circuit and it will look something like this, where you have one single resistor here and the other resistor over here. This is R3 and this is R1 plus R2. Okay? Because we just simplified it using the series rule and we simplified it to get this R1 plus R2. Or a more clear way of putting it, let's call this R12. Okay? And R12 is equal to R1 plus R2. Now when we look at the series, now we're done with the first circuit. Now when we look at the connections here, this is our VS, all right? This is our current IT. Now, if we look at the connections here, we are going to have 2 points of connections. We're going to have a point here and a point here between R12 and R3. So these two, okay, are in parallel. In other words, we can say that R total now, the final R total, is going to be equal to R12 times R3 over R12 plus R3. Or you can say that 1 over RT is equal to 1 over R12 plus 1 over R3. Since there's only two resistors, we can use the simplified shortcut. And this equation, again, is going to be given in the formula sheet. But this is how you would be able to simplify it in this case. All right, let's look at another example. Let's say we had, so basically this is our R total. Before moving on, let's draw our final simplified circuit. It is going to look like this, where you have your current now IT, which you can find, and you have your voltage supply here. And now you have R total here that you have found earlier using this equation. All right, so R total. So now we can use R total to find our current. So I total is going to be equal to Vs over R total. All right, this is what you're going to have to do to find your total current that is flowing through the circuit. Tamam? Now let's look at another example. Let's say that we have it in this way. Say the battery is here. Actually, let's do it this way. So let's say we have a resistor over here. All right. And then we have a resistor over here. Resistor over here. And let's do one more resistor over here for fun. And then go back down here. So let's call this R1, R2, R3, R4. And we have our voltage supply here, Vs, plus minus. And this is our current direction over here, I total. Okay? So the first thing we're going to look at here in this case is we're going to look at this parallel connection that we have. How do we know it's parallel? We have 2 points of connection. We have one here and we have one here. These two are connected at 2 points. So we know that this is a parallel connection. And what is the equation for parallel? R23 is going to be equal to R2 times R3 over R2 plus R3. Tamam? This is how you would simplify this. And once this is simplified, the circuit is going to look something like this now. So we're going to have our voltage supply here. We're going to have our R1 over here. We're going to have one resistor here replacing these two resistors, which is R23 that we found the value of. And then we're going to have another resistor over here, which is R4. And this is our voltage supply, and this is our current, I total. Okay? Again, same idea. Here, we're going to look at their connections. If you notice, there's 1 point of connection between R1 and R23, and there's 1 point of connection between R23 and R4, all right? Let me actually use different colors so that there's no confusion. And there's one point of connection here between R4 and R3. So we know that all these three are in series. So now we can say that our R total is equal to R1 plus R23 plus R4. And now if you want to draw our equivalent circuit, it's going to look something like this with a single resistor. Again, it doesn't matter where you draw your single resistor. You could have drawn it here. That would also be correct. Or you draw it here. That is also correct. Because remember, these are just wires and you can move them around. And then a plus minus Vs. And we have I total هني. And this is our total. Again, to find I total now, very simply, all you just do is Ohm's law. It is Vs over RT. Okay? Same exact idea. Let's do one more example with numbers this time. Let's look at this circuit over here. All right? So if we have this circuit, the first thing we can notice is the parallel connection that we have over here. Why is this a parallel connection? Because we have 2 points of contact. Okay? Try to always go look for the easiest one to simplify when you are doing so. All right. Usually it's going to be the furthest from the voltage source, usually, and it's going to be farthest away from a 9-volt battery. In this case, this one is basically the most easy to simplify in the circuit. So we're going to start with this one. How do we simplify this? Since this is a parallel connection, parallel, معناته we can say that R, all right, is equal to 8 times 8 over 8 plus 8. So we're going to find out that R is equal to 4 المفروض, but let me just make sure. Yep, it is 4 ohms. So now if we want to redraw the circuit, then it is going to look something like this. A second. Once we simplify that, now we have a circuit that looks like this, where if you notice this connection over here, this 4 ohms, we got it from over here, all right, from the 2 parallel that we simplified initially. Now we can look at these two. Now we can look at these two, which are in series. How do we know they're in series? There is only one point of connection in between them over here. So these two are in series. And we can simplify it. How do you simplify for series? R is going to be equal to 6 plus 4. So R is going to be equal to 10 ohms. So now we can draw it over here. If I just draw it myself, it's going to be something like this, where this is 10 ohms. And this is our 10 ohms that we just found. There's another resistor over here, 3 ohms. And we have our battery over here. This is 1 ohm. And this is 9 volts. So again, this 10 ohms over here, this came from this series connection. All right, this total series connection over here, where we found out that R is equal to 10 ohms. Now, when we look at this circuit, we can notice that now these two are in parallel. How do we know these two are in parallel? They are connected at 2 points to each other. So this is another parallel connection. Parallel معناته the resistance equivalent for them is going to be 10 times 10 over 10 plus 10 because it's parallel. So we apply this rule. So R is going to be equal to 5 ohms. So now if I want to redraw the circuit, all right, we're going to have one resistor here, which is 3 ohms. This is our 5 ohms. And one resistor here, and our source of 9 volts. Okay. Again, where did we get this 5 ohm resistor from? How did we simplify it? It's from these two connections to each other. All right. When we connected these two together, when we connected these two together, or when we did the combination of parallel, we found out that the total resistance is 5 ohms, and we just put it back here in the circuit. Now it has been simplified. We know that these are all connected in series to each other. The 1 ohm and the 5 ohm are in series, and in series also is the 3 ohm, because there's only one point of connection between all of them. So we can say that our total now is equal to 1 plus 5 plus 3. So our total resistance now is 1 plus 5 plus 3, which is equal to 9 ohms. So our final circuit is going to be like this. Remember, current is flowing in this way, I total, from the source. This is V source, and this is our 9 ohm resistor that we have found over here. This 9 ohms. This is how we got this, which is just all the 3 series connections together. All right? Series. Okay? And now if we want to find our I total in this circuit, it is simply equal to Vs over RT, or in this case, Vs is equal to 9 volts, over the total R that we found, which is 9. So it is equal to 1 ampere. That is our total current going through all of it. This is how you do your simplification for any circuit, for a combination circuit, and this is how you can find the current that is flowing through any of this. When I checked with Mr. Isa, he said that all you need to worry about is I total. All right, you don't need to worry about the currents that is going through in 10 ohm resistor or whatever. Just make sure you know how to do the reduction so that you know how to combine them and find your I total and R total, and that's pretty much it. All right. So make sure you know how to find R total for any circuit, and for I total, obviously that comes with practice. Okay, let me see if there is any other circuit. Let's look at this one. Before we move on to KVL and KCL, let's look at this. Okay. So this is the circuit that we have. Okay. Again, same idea. Okay. Remember when I told you that all this means it's ground, right? So as if this is closed over here, there's a line, which is your ground line, all right? It's the same thing. So this is what the circuit basically looks like. So when you have ground, it basically means it's the same line. Now we can look at the actual combinations that we have. So let's start with here. If you notice here, this is the easiest one we can do, or we can also do the top part, which are in series. It's up to you, whichever is simplified. Either way, and you're going to simplify all of it. Whichever is easier for you to see first, do that one. So in this case, if you notice, we have two connections, one here and one here. So these are in parallel. And if we want to do for the top two, okay, there's one connection only between them. So معناته these are in series. All right. So for the series one, it's going to be R2 plus R3. So, or let's call it R23 is equal to this. So R23 is equal to 47 plus 47. So R23 is equal to 94. Yes, 94 ohms. Okay. For the parallel connection down here, this is going to be R4, 5. It is going to be R4 times R5 over R4 plus R5. So in other words, R4 and R5 is 68 times 39 over 68 plus 39. R4, 5, if you put it in the calculator, 68 times 39 divided by 68 plus 39. This is going to give us a value of 24.79 ohms. So if we want to simplify the circuit a little bit now, we can simplify both of these two in one step. So the first thing I'll do is draw our voltage source over here, or our battery. Okay. Then we have a resistor R1 over here. So this is R1. Okay, then it will break off down and up. Let me make some space. So down and up. And remember here, we already did our combination for series, which is R23. So here we have R23. Again, this is just the purple part. All right, the purple circle over here. And then at the bottom, we simplified these two parallel, the R4 and R5. So here we have R45. All right, again, this is just the blue simplification that we did earlier. And it is connected to another resistor down here, which is R6. And both are connected back to the ground, or you can simply say they're both connected in this way, back to the negative side, because both of them are connected to ground, which is just the same thing. Tamam? Now we are going to look at this and do the same exact simplification again. We notice that this is the easiest simplification we can do, and they're connected in series. So we're going to do R45 plus R6 because they are in series, right? And we'll call it R456, يعني, which is equal to R45 was 24.79 plus R6, which is 75 ohms. All right, 75 ohms. So R456 is equal to plus 75. We get 99.79 ohms. All right, and this is our voltage supply over here, PS. Okay, again, same thing here. Now we simplified the series part, so we can redraw the circuit again. So if I want to redraw the circuit, again, we have our voltage supply here, or our voltage source. We have a resistor, and then we have a resistor up here. And then now we have one singular resistor down here. And that's pretty much it. And then it goes back to the voltage source. This was R1. This was R23 from earlier. And now this is R456 that we have found from the red circle above. Again, you will keep going. We'll do the same thing again here. If you notice now, they are connected at 2 points. معناته these two are in parallel. So R2, 3, 4, 5, 6 is equal to R23 times R456 over R23 plus R456. In other words, this is equal to R23, we found it earlier to be 94. So it's 94 plus 99.79, times 99.79 over 94 plus 99.79. So now we find our R2, 3, 4, 5, 6. Basically, in other words, this means it's the equivalence of all these resistors combined. Just put those numbers in the calculator. So 94 times this over 94 plus this. You're going to get 48.40 ohms. All right. So now we again can redraw the circuit not one last time, maybe two more times. So this is R1. And now we have combined these two. So we have just one more resistor over here, which is R2, 3, 4, 5, 6. And then this is going back to the ground. Okay. This again is just from the orange part earlier that we did. Here, it is very straightforward. These are in series with each other because there's only one point of connection. So series. So R total is equal to R1 plus R2, 3, 4, 5, 6. R total is equal to R1 was 100 ohms plus R2, 3, 4, 5, 6, which we found earlier, is 48.40 ohms. So R total is equal to 148.40 ohms. So our final circuit is going to be just one resistor, like that. R total, which is equal to 148.40. Again, this is just from the calculations above of the series. and our voltage supply, and obviously our current is going in that direction. This is our I total. Okay. The question here was just asking to find the total resistance. So the final answer is just your R total, which is 148.40. All right. Any questions about reduction, about multiple uh, resistors? Anything about that? Anything not clear? No? Okay. Then let us move on to the final concept you guys need to know for the exam. Let me just see if there's any question that I would like to do here. This is okay. They're all very similar to what I explained. All right. Let us move on to KCL and KVL, also known as Kirchhoff's laws. All right. So we basically did cover it very slightly, but let us look at it clearly. So we have something called Kirchhoff's laws. We have two of them. The first one is the current law, sometimes called as KCL, meaning Kirchhoff's current law. Okay? What does current law say? It says the summation of I at a specific junction or node is equal to 0 at a node. What does this mean? It means the sum. Remember, when you see summation, معناته بس you're adding everything at that point. Okay? So what does this exactly mean? Let's say we have wires over here, all connected to this one point. Okay? And let's say we have a current over here, I1, a current over here, I2, it's going outside, another current here, I3, also going outside, another current, I4, going inside, and a current, I5, that is going outside. Okay? So we have these 5 currents. Okay? The way you guys can look at this is that all of this, when you add them all up, it has to be equal to 0. But what is very important here, it is direction. Okay? So if you notice here, this is going in, this is going out, this is going out, this is going in, and this is going out. And everything at this point, when you add them all up, it has to be equal to 0. So the first thing you need to know is you need to define that entering, for example, is going to be your negative value, and exiting is your positive value. Okay? Again, this doesn't matter if you say it the opposite way. You can put it in any way you want. This is just to define a specific direction. يعني انتوا تبون بس تحددون ان لو قاعد يدخل بيكون negative واللي قاعد يطلع بيكون positive. You guys can swap it, but I usually follow this convention. So what does that mean? Now let's look at I1. I1 is going inside. It is entering. So we can say that minus I1, the I1 is going to be a negative value because entering is negative. All right. Entering is a negative value. Let's look at I2. I2 is exiting. So exiting is a positive value. So معناتها it's plus I2. Let's look at I3. I3 is also exiting. قاعد يطلع من النode. All right. So when I'm saying entering and exiting, I mean entering and exiting this point over here. Okay. This junction where they are all connected. So I3 is going outside of it, so it's exiting, so it is a positive value. I4 is going in, so it is a negative value. And I5 is going out, so it is a positive value. And all of these is equal to 0. This is what current law basically means, all right? Current law basically means when the summation at a node or at a junction, I should say, instead of a node, at a junction, زين يعني تقاطع بما معناه زين هني كل الكرنت اللي قاعد يدخل لازم يساوي او كل الكرنت اللي قاعد يدخل ويطلع يوم تحطونهم مع بعض لازم يساوي 0. Another way of looking at this is, if we're looking at the same exact example, we can say that, okay, or entering is equal to exiting. Okay, يعني current entering, I should say, I entering is equal to I exiting. It will give you the exact same equation. All right. So if we apply this equation, I1 is entering plus what else is entering? I1 is entering, I2 is exiting. So if we look at all the things that are entering, we have I1 going in and I4 going in, and everything else is exiting. So these two are the entering currents. So I1 plus I4 is equal to, now we look at everything exiting, the remaining values are the ones that are exiting, which is I2 plus I3 plus I5. Okay? This is also Kirchhoff's current law, just in a different way. Because if you notice, these two equations are exactly the same. If we take these two values to the other side, they're going to become negative, right? If we take these two values to the other side, so if I just copy paste this down here, if we take these two values to the other side, like this, they're going to be negative now. So this is going to be minus, and this is going to be minus as well. And this is going to be 0 over here. So if you notice now, this equation is exactly the same as the equation we got earlier up here, which is minus I1, so minus I1, and minus I4, here also minus I4, and everything else is positive, and it's all equal to 0. It's all equal to 0. So these are the two different ways you can do the Kirchhoff current law. All it says is at a specific junction, يعني at a specific point, all the current entering is supposed to be equal to all the current exiting, or you can say that the summation of all the current at a specific point is equal to 0. All right? Very straightforward, very simple. Now, what about the voltage law? So we looked at the current law. What about the voltage law? Or KVL, Kirchhoff's voltage law. It's the same exact idea of current. Well, not the same, but it's a very similar idea to the current law, but in a different manner slightly. And let me show you how. So let us say we have this circuit. All right, we have a resistor here, another resistor down here. And we have a voltage source over here like this. Okay, this is minus plus. Here, polarity is very important, and minus plus. Polarity meaning the positive and minus. So here, what does KVL say? It says the voltage that is going around the loop has to be equal to 0. So in other words, it's saying the summation of voltage in a loop should be equal to 0. What does that mean? معناته we are going to be going in a circular direction like this, and when we reach back over here at this point, the voltage has to be 0. And how do we apply that? So let us give some numbers here. So let's call this V1, let's call this R1, let's call this R2, and let's call this R3, and let's call this V2. Okay? So we have to first assume a direction for current. Assumption, based on you. It doesn't matter which direction, whether clockwise or counterclockwise, okay? So let's say current is flowing in this direction. Remember, this is a series circuit, right? So current is the same all over the place. It does not change. Current I. Okay, everything is connected in series. So KVL says that when you're going in this loop of current, all the voltage has to be 0. So let us do that. Let us start from this point, all right? One rule you need to know is that when current is going from, so let me write this down here actually, because this is very important, minus plus. So we know in a battery, this is the minus side and this is the plus side. So when current is going in this direction, all right, that means this is a voltage gain. Or in other words, this is a positive value. Okay, so when it is going from minus to plus, you can think of it as if current is going upwards. So it is a positive value. In the opposite direction, so let's say we have something like this. All right, let me just put this a bit down. So if we have something like this, now if we look at current, current is flowing this way. All right, current is going from the big to the small, so it's going from positive to minus. In this case, this is what they call a voltage drop. يعني الفولتج قاعد يطيح، يعني قاعد يقل الفولتج drop. Okay? This is going to be a negative voltage. So when you're going up, it is positive. When you're going down, it is negative in the case of a battery. And for a resistor, if you remember early on in the session, I said that when current is going through a resistor, it is always going from plus to minus because there is always a voltage drop in a resistor. دايما. Resistor will always cause a voltage drop. If it's going from plus to minus in this case, this is going to be a negative value as well. All right. So when it's going from minus to plus, or from the smaller one to the bigger, it is going to be a positive value. When it's going from plus to minus, the current, it will be a negative value. And when it's going through any resistor, it is always going to be a negative voltage drop. تمام? In the case of one current, which we have right here. So using this rule, let us apply it to this circuit over here. Okay, let me take it a bit to the side. So again, how do you do this? You start at a specific point and you move in the flow in the direction of current. So we're going over here. All right. If you notice here, current is going from down to up, from minus to plus. So we're going to write plus V1. All right. That is our first value. And then current now is going onto a resistor. When it's going onto a resistor, it's going to be a voltage drop, right? Remember that when current is flowing to a resistor, the polarities are going to look something like this. Plus minus, plus minus, plus minus. Because we're going through a resistor, it's always going to be a negative value. So negative V R2, the voltage drop across R2. All right. Same thing for for R1. My bad. We're starting with R1 here. All right. Same thing for R2. When we're looking at the current is now flowing like this. All right. So it is going to be a drop. So minus again. This is VR2, sorry, minus VR2. Okay. Same thing for R3. This is VR3. So minus VR3. When it goes through the resistor, it's always going to be a drop. It's always going to be negative. Now we are coming to another source, another voltage source. The current is going from plus to minus. It is going downwards. معناتها it is negative. When it goes from plus to minus, معناتها it's falling. It's a voltage drop. So it's going to be minus V2. This is V2. And this is all going to be equal to 0 because now we reached this point and we came back and we closed our loop. All right. So when this is the idea, we start from a specific point, like starting here. All right. And ending here as well. You're going to go in a circular motion. So you're going to go like this, like this, like this, and back to this point. Okay. Remember, VR1, if you use Ohm's law, VR1 is simply just I times R1. Remember that current is the same. It's just a series circuit. I is flowing everywhere. So VR1 is simply just I times R1 minus VR2 is simply I times R2. VR3 is I times R3 minus V2 equal to 0. And this is how you apply KVL. All right. It is very important to understand these three concepts. And when you have a resistor, it's always going to be a voltage drop. When you have current flowing from the negative side to the positive side, it is a voltage gain. So I'm going to just mention that from negative to plus. So from minus to plus, that means it's a gain. So the value is positive. All right. From positive to negative, or from plus to minus, this is a drop. So it is going to be negative. All right. And then you're just going to start at a specific point and you're going to be following a loop. All right. I'm going to do some examples in the mock test tomorrow about all of this. So don't worry, we're going to cover a lot of examples. This is just the idea of how you apply them in general. I hope you guys do attend tomorrow's session.